in class. I hope you're taking care of yourselves, and I know I've been praying for each of you and your families. I just want to start off by telling you, please reach out if you ever have any questions, or if you're struggling to keep up with anything. I know it's hard at home. Please make sure you reach out to me, and I'm happy to help. This video today is going to go over section 6.5. So 6.5, we're actually going to do homework for the next 2 days over it, and it's not a crazy hard section, but it does involve a little bit of work. So let's go ahead and get started. This video isn't too long for you, so let me go ahead and share my screen here. So if you remember what we're talking about triangle similarity. So triangle similarity means that we have two triangles and we want to know if they're similar to each other or not. So similar is different than congruent, right? Congruent means exactly the same. Similar means same shape, different sizes. And so last week we learned to prove two things are similar, we have to have two things to be true. All the angles have to be the same, and all the sides have to be proportional. And then we learned a shortcut last week. We learned that there's the angle-angle similarity postulate. So that just applies to triangles. But if you have two triangles and two angles of one triangle are congruent to two angles of the other triangle, then those triangles are congruent. So we don't even have to know anything about the sides. So that's pretty cool. But today what we're going to learn about is we're going to learn two more theorems that have to do with shortcuts to proving similarity in triangles. Okay, so the first one we'll just go ahead and jump right in is right up here on the front of your screen. It's called the side-side-side similarity theorem. So you feel like you're having flashbacks to congruency, right? So we have the side-side-side congruent postulate. Well, the side-side-side similarity theorem, SSS similarity, is a little bit different. So what this one says is if the corresponding side lengths of two triangles are proportional, oops, it would help if I had my thing on here, are proportional, then the two triangles are similar. So if we're trying to figure out if two triangles are similar to each other and we're not sure, originally when we were talking about proportionality, we had to check all the angles, right? And then all the sides. That's true for any figure that's similar. When you're talking triangles in particular, as long as all of the side lengths are proportional, we don't have to check the angle lengths. So in this theorem, you'll see right here, it says we have these two triangles, ABC and RST. If AB over RS, so if I compare the ratio of AB over RS to BC over ST to CA over TR. If all of those ratios are equal to each other in a proportionality statement, then we can say that the two triangles are similar to each other. So to do this isn't really too difficult. It's just honestly a little bit time consuming. So let's go ahead and dig in so you're not watching this forever, right? So the first one here says, is either triangle DEF or GHJ, so we've got DEF right here and GHJ here, are either of those similar to ABC? So a lot of people want to just look at them, but you can't necessarily look. We have to check, right? So let's see, is triangle ABC similar to DEF? So let's compare the first two here. Okay, so what they've done is they've flipped the triangles around a little bit, right? But remember, we can always use our proportionality statement to help us out. So we want to know, our question is ABC similar to DEF? Okay, and so if that's true, then the proportionality statement has to be true. So notice I'm not even looking at my triangles over here to the left. I'm using my similarity statement. So AB over DE, right, the first two letters, would have to be equal to BC over EF, the second two letters, and that would have to be equal to CA over FD, the third and first letter, right? So I got all that out of my statement. You can try to look at the picture and figure it out. You're welcome to do that if you're more visual. That is also a way that you can do that. So then what I do is I check the numbers. So A to B is 8, D to E is 4. Okay, does that equal B to C, which is 9, over E to F, which is 6? And then C to A is 12, and f to d is 4. So is this true? Well, I can't quite tell here. I actually kind of know, but let's simplify our ratios here, right? So 8 over 4 is 2 to 1. 9 over 6 is actually 3 to 2. And 12 over 4 is 3 to 1. Yikes, right? So are our triangle ABC and DEF similar? No, they're not similar. Okay, not similar. So let's go ahead and try out the second set of triangles and see if they're similar to each other. Okay, my mouse isn't acting up here. Where are you at, mouse? Come back. There we are. Okay. So let's erase this off here. Okay. All right. So let's go orange. Now we want to say, is ABC similar to GHJ? So is ABC similar to GHJ? Is that true? So again, I don't even look at the picture. I mean, you can probably look at this picture, but I just go straight for the statement. So is AB, this is a proportionality statement, AB over GH, does that equal BC over HJ? Does that equal CA over JG? Oh, I should have saved it. A to B is 8. G to H is 16. B to C is 9, H to J is 18. This is looking promising, right? And C to A is 12, and J to G is 24. So if you notice all of these, they all simplify to 1/2. And that's a good thing. So my triangle similarity statement is true. So then yes, this is true. Yes, they are similar. All right. So that's how you do it. Not too hard. You don't have to check the angles. You just have to check the similarity statement for a triangle. So another way that we could do this is to use the side-side-side similarity theorem. Because remember, it's a postulate and for congruency. Yeah, let's try to, whoa. My mouse is acting up, so sorry about that. Okay. So one more problem we can do with that is this example number 2 down here. So example number 2 says, find the value of x that makes triangle ABC similar to triangle DEF. All right, so let's do example number 2 over here. Okay, so again, if they are similar, we know that AB, I'm using my similarity statement, right? AB over DE has to equal BC over EF has to equal CA over FD. So now I go to my picture. A to B is x minus 3. D to E is 20. B to C is 4. E to F is 10. C to A is 10. And D to F, F to D is 2x plus 3. Okay, so now I want to figure out what value of x that makes this true. Okay, so what you'll notice here is we've got this proportionality statement, but if I pull out 2 of the terms, then I have a proportion. So I'm going to solve x using just this first part here, right? And I know that x minus 3 equals 20, or x minus 3 over 20 equals 4 over 10. Well, I'm going to make it even easier myself. I'm going to make this 2 out of 5, just so I make it easier. To solve this, right, it's a proportion, so we're going to cross multiply. So all that practice cross multiplying, now it comes in handy, right? We've got 5 times x minus 3. So don't forget, it's everything over here in parentheses, equals 2 times 20. Okay, so we get 5x minus 15 equals 40. Or 5x add 15 to both sides equals 55. Or x equals 11. All right, x equals 11. So if x equals 11, and I plug that back into my proportionality statement, it's 11 minus 3. So this becomes 8. So is 8 over 20 the same as 4 over 10? Yep, that works out. Now, I have an x over here, right? They actually included 2 x's if I include this proportion. Let's just double check that x equals 11 actually works here. So if x equals 11, it would be 22 plus 3, so 25, right? Is 10 over 25 the same as 4 over 10? Let's see, they both reduce down to 2/5, so that works out too. So we know that x equals 11. All right, so nothing too hard, more just algebra application kind of stuff, just to make sure that the triangles are proportional to each other. Okay, so that is the first theorem. The second theorem that we're going to talk about is, dun, 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 dun. Let me erase some of this off here so it's not so crazy. Here, we'll just erase that all so it just doesn't look so busy. Okay, so we have, so far we have angle, angle, right? And we have side, side, side similarity. So we're talking similarity. How can we tell two triangles are similar? We have angle, angle. We just learned side, side, side. And the third one that we have for similarity is the side, angle, side. So the SAS, another SAS coming back for us. So let me go ahead and read this theorem to you. Make sure you get this in your theorem sheet. It says, if an angle of one triangle is congruent to an angle of a second triangle, so right now we're talking about, if you look at this picture, we're talking about angle X and angle M. They're congruent to each other. And the sides including these angles, so including is the important word, are proportional, then the triangles are similar. Okay, so remember this idea of including, and side, angle, side means the angle has to be the included angle. When we're comparing proportions, we need to look at the two sides that touch that angle in order to see if side, angle, side works. So you see in this little phraseology down here, it says if angle X equals angle M and ZX over PM, so that's these two sides here, is equal to XY over MN, so that's these two sides over here, then the two triangles are similar. So again, side, angle, side, you should be familiar with it. Those sides have to be proportional and they have to be touching the angle. So that's the important thing for that. Okay, so let's do a problem with this. Okay, so let's look at example number 4 here. And it says, example number 4 down here, right? It says, tell what method you would use to show the triangles are similar. So we've got two triangles here. We need to know if they're similar. It's a little bit of a mind trick, I feel like, when I look at this. But we have our good friend, vertical angles, right? That lets us say that PRQ is congruent to TRS. All right, good friend vertical angle is back again. So once I mark my vertical angles on there, I'm like, hey, I just learned about side, angle, side, and I have side, angle, side going on here, right? So to use theorem 6.3, side, angle, side, SAS similarity, right? I have to show that an angle is congruent to another angle on the other triangle. So I've got angle PRQ is congruent to angle TRS, and that's thanks to vertical angles. Our favorite one, right? The angles theorem. Okay, we got that down. So for side, angle, side similarity, now my included sides, the ones that are touching that, have to be proportional. So that means that Q to R over S to R has to equal R to P over R to T. So let me say Q to R, right? This side over this side has to be in a proportion with this side over this side. They have to be proportional. All right, so QR is 9 and SR is 12 and RP is, oh, I just wrote over 18 and RT is 24. Okay, so I have to know, are these proportional? So you could cross multiply or we could simplify them both. So 9 over 12 is 3/4, right? And 18 over 24, those both can be divided by 6 is also 3/4. So guess what? The angle is congruent, one angle is congruent, and the side lengths touching it are proportional. So then I can say by side, angle, side similarity that triangle QRP is similar to triangle SRT. So there we go. All right. Not too bad. Feels a little bit like what we did with congruency, but a little bit different, a little tweak on that, right? Okay, last, well, let me just talk about number 4 instead of you guys watching me do all the math on number 4. So number 4 says, show that JKL, so here's JKL down here, JKL is similar to LKM. So, ooh, I'll switch colors. LKM. All right, I've got these two triangles down here, and how would I show that those two are similar? So of all of my choices, I've got angle, angle. Well, I don't have any angles marked on here. I've got side, angle, side. I really don't have any angles still marked on here, right? Or I have side, side, side. Do I have side information about the blue triangle and the red triangle? Yep, I do, right? So how I would find that those two triangles are similar is I would check using the side, side, side similarity theorem, right? That's what I would use to check these two, theorem. There we go. And just so you know, if you do want to go ahead and check them, then all of them would actually be in a ratio from JKL to LKM. They would be in a ratio of 7 to 4. So they actually do check out that the two triangles are similar to each other, but we would use side, side, side to do that. Okay, so the last thing I just want to share with you is this little chart here, which is not anything too fancy, but these are the 3 ways that you can prove triangles are similar to each other. So remember when we did congruence, we had 5 ways. When we are talking about similarity, we have 3 ways. So the 3 ways are we have the angle-angle similarity postulate, and in case you're trying to keep back up with your notes, that's postulate 22. Okay, and we have, so that was what we just learned in the last section. We have the side, side, side similarity theorem. Oh, sorry, angle-angle similarity postulate says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Side, side, side similarity says if your proportionality statement is true, all your sides are proportional to all the sides, then the triangles are similar to each other, and this happens to be theorem 6.2, okay? And then the side angle side is the one that we just learned. So this one is if angle A is congruent to angle D, so one angle, and then the sides that touch it are proportional, then they're congruent to each other. So this is theorem 6.3. All right, so that is everything for section 6.5. Like I said, the homework is over that for the next 2 days, but I will go a little bit into 6.6 today, so I'll be sending that video out later. As always, guys, I really thinking of each of you. If there's anything that, here, let me switch my, there we go. I'm thinking of each of you guys. If there's anything that I can do, please reach out, and I miss you all, and take care. All right, bye, guys.